Hello everyone, Ramya, Assistant Professor of CSE Department from Rohini College of Engineering and Technology, subject code CS 8591, Computer Networks, Unit 2, topic Data Link Layer Protocol. In Data Link Protocol, we have four protocols have been defined for the data link layer to deal with flow and error control. There are four types of data link layer protocols: simple, stop and wait, go back and selective repeat. First, we are going to see the simple protocol. That means it is one of the first protocol. It is also a simple protocol with neither flow nor error control. Here we have to assume that the receiver can immediately handle any frame it receives. In this diagram, it shows the data link layer at the sender gets a packet from its network layer, makes a frame out of it and sends the frame. The data link layer at the receiver receives a frame from the link, extracts the packet from the frame and delivers the packet to its network layer. The data link layers of the sender and receiver provide transmission services for their network. Next, we are going to see the FSM. That means the sender side should not send a frame until its network layer has a message to send. The receiver side cannot deliver a message to its network layer until a frame arrives. Each FSM has only one state, the ready state. The sending machine remains in the ready state until a request comes from the process in the network layer. When this event occurs, the sending machine encapsulates the message in a frame and sends it to the receiving message. Here the receiving message remains in the ready state until a frame arrives from the sending machine. When this event occurs, the receiving machine decapsulates the machine out of the frame and delivers it to the process at the network layer. Next, we are going to see the stop and wait protocol. It is one of the second protocol that is called as a stop and wait protocol. Here we uses both flow and error control. In this protocol, the sender sends one frame at a time and waits for an acknowledgement before sending the next one. To detect corrupted frames, we need to add a CRC to each data frame. When a frame receives at the receiver side, it is checked. If the CRC is incorrect, the frame is corrupted and silently discarded. The silence of the receiver is a signal for the sender that a frame was either corrupted or lost. That means using this you can able to send initially in the ready state, but it can move the ready state and the blocking state. That means in this diagram it shows when the sender is in the state, it is only waiting for the packet from the network layer. If a packet comes from the network layer, the sender creates a frame, saves a copy of the frame. Then the sender moves to the blocking state. Here the blocking state, what they will do means when the sender is in the state, three events can occur. If a timeout occurs, the sender resends the saved copy of the frame and restarts the timer. If a corrupted acknowledgement arrives, it is discarded. If an error-free acknowledgement arrives, the sender stops the timer and discards the saved copy of the frame. It then moves to the ready state. Next, we are going to see the piggybacking. That means the two protocols in this session are designed for unidirectional communication, in which data is flowing only in one direction through the acknowledgement may travel in the other direction. Protocols have been designed in the past to allow data to flow in both directions. However, to have the communication more efficient, the data in one direction is piggybacked with the acknowledgement in the other direction. Thank you.